that you end up with fewer inputs, fewer expressions, and that jacks up the reliability of the whole operation. Okay, you got a lot. Unreliability is directly proportional to the number of inputs that you've got and the number of kind of operations that you're doing. So we would like to simplify things down. All right, so last time we went over Boolean algebra. I have no intention of asking you to remember that or to solve or reduce problems down with Boolean algebra. We got a much simpler way to do that. But we need to still know a few things out of that. One is that if you have x or 1, what is that really equal to? Just 1. If you had x or 0, that's equal to what? Yes. Okay. If you have x ANDed with 1, that's what? X. If you have x ANDed with 0, that's going to be 0. All right. Very good. Okay, the other one that you really need to know is De Morgan's theorem. And so if you had A plus B and you negated that, you end up with what? Okay, not A ANDed with not B. All right? If I had A, B, C, all of that negated, I'd end up with what? Okay, not A or not B or not C. Doing okay? What would happen if I had A, B bar, C bar, and then I negated the whole thing? Okay, A bar or B bar bar or C bar, but double negatives make what? Positive. So you see that this would be A bar or B or C bar. Is everybody doing okay? All right, great. Okay. So briefly we talked about truth tables. A truth table is what? You list all the variables, all the possible variables that thing is a function of. You list every possible combination that you can of the inputs and see what the output of that function is equal to. Is that okay? All right. So if two functions have exactly the same truth table, what can you tell me about the functions? They're equal. Is that right? Okay. So the truth table is a good way to see how the function plays out, if you will. All right, so let's say that I have the function is equal to x. If I added a 0 to that, you'd still end up with what? X, right? If I ANDed it with a 1, I'd end up with x. All right. So let's say this is OR x, y bar. What do you suppose that's going to be equal to? Does it matter what y is doing? Let's go ahead and take a look at it here. So we'll do our truth table. So we'll do it in segments here. So what are the possibilities in accounting code for the variables x and y? 0, 0, 0, 1, 0, 1. Excellent. Okay. All right, now I broke the function up into its pieces, if you will. All right. So when I have 0, 0 for an input, what's x? 0, 0. That was a hard one. 0, 1, 0, right? 1, 0, 1, 1. You see, it doesn't matter what y is doing. All right. What about x and y bar here now? What do I end up with? X is 0 going in, y is 0. That comes out 0 and 1, which is 0. Okay, now 0 and 1 going in, I end up with 0 anded with 0, which is okay. 0 and 1. 1. Everybody okay with that? I'm going to end up with a 1. Why? Because y bar becomes 1. 1 and 1 is 1. 1 and 1 for input, 0. Now, what we're doing here is our function is ORing those guys, correct? Okay. So 0 or 0? 0, correct? 0 or 0? 1 or 1? 1 or 0? What do you notice? It's the same thing as x. Do you understand that I could take this expression here and say that's just equal to x? Does not matter a bit what y is doing. Do you see how I've simplified it down? I've reduced it from 2 variables to only 1 variable. Now, you can use the postulates and the theorems of Boolean algebra to solve this, okay? But we'll do it with K-maps. Everybody all right so far? Yes? No? All right. Now, the K-map here's how we're going to do this. How many inputs do I have? 2. 2 to the 2. Do you understand? There are 4 possibilities of the inputs. Yes? Okay. So I'm going to make a 4-cell map. Okay. On here I'm going to have x. Here I'm going to have y, and this whole map is the function f. Okay. What are the possibility for the x's? What can it take on? 0, 1. 0, 1. How about y? 0. Okay, 0, 1. Now what we're going to do is we're going to fill in 1s and 0s for each cell. So 0, 0 going in, what's my function?
0,
0, 1, what's my function?
0.
I'm a little bit more enthusiastic about that. 0 and 1, what's the output? 0. 1 and 0, which is this guy here, what's the output? 1 and 1, which is this cell, another 1. Okay, what we want to do is find groups of 1s that are powers of 2. Okay? Do we have 4 1s in this cardinal map? What would happen if I did have 4 1s? F would be 1 or true. Wouldn't matter what x and y are doing. Okay? So you always try to go with your biggest power of 2. Now, when you're putting a 1 into a group that's a power of 2, you have to be able to get from each 1 to another 1 eventually by only having 1 variable change. So can I get from here to here by having only 1 variable change? And that variable is what? Y. Everybody okay with that? Yes? Okay. What would happen if I had this function? Do I have a group of 2? The answer is no. Can I get from the one up here to this one through some path by only having one variable change at a time? The answer is no. Do you understand that if I go from here to here, both the variables have got to change? So I cannot take this group of 2 and put it in, or this group of 2 ones and put it into a group of 2. Everybody all right with that? Now, back over here I could. So I'm going to circle, and my function is just x. Does not matter what the y is doing, it's just x. Which is what we ended up with our truth table. Do you understand that the Carnot map and the truth table exactly have the same thing, but with our Carnot map we can go ahead and this is a simple one, it's only 2 variables. We can reduce it down. Question?
Can you make the statement again about the groups of 2 and the variable changes?
You have to, it's going to become more clear in just a second, but you have to be able to go from any one to another one in the group through a path where only one variable is changing at a time.
So is it kind of like the grade? Is it?
You're going to see that we're going to have to put our variables here in terms of a gray code in order for it to work. Otherwise, it will not work. Everybody's still with me so far? Yeah.
And the reason you can say this is f equals x is because when you go from the first column to the second column, y changes and you wind up with the same result.
It doesn't matter what y is doing.
So what does it mean since the other map doesn't give you what you want?
Oh, I would still have to do it. This guy here, I could not simplify it down. I cannot group the things. And so my function is, okay, how do I do, what variables give me this lonesome one here?
Not x.
Not x and y. Everybody understand that if x is a 0, okay, then not x would be what? 1 and 1 is, all right? Now, I've got to cover this guy here, this lonesome 1. What do I have to do here? X, y bar. Is that okay with you? Say it one more. Yes, they're ANDed.
All right. And so the or is each option.
That is correct.
Okay.
All right, let's try a different function here. So my f, in order to be true, I have a, if a is a 1, b is a 0, c is a 1, will my function be true? Let me repeat that. A is a 1, b is a 0, c is a 1. Will my function be true? Yes, because what happens? That lights this guy up with a 1. I'm worrying it with junk, but who cares, right? Doesn't matter what that junk is. This guy's a 1, that means my whole function's going to go. Doing okay? Now, probably didn't help myself here. Let's, okay, let me make one change in this. I'm going to put a bar over that one there. Okay, so how many, I could do a truth table, correct? How many rows in the truth table?
3.
How many? How many rows in the truth table? 8. Why? Because 2 to the third is 8, one of those powers of 2. All right. I'm not going to do the truth table. I'm going to go ahead and go directly to the K-map. How many cells do I need in the K-map? 8. All right. Lots of ways, well, a couple of ways that you can do this. I'm going to do it like so. Okay. See, I got 8 cells. Yes? I'm going to do A and B over here and C here, and then my whole table is my function F. What are the possibilities for C? 0 and 1. What are the possibilities for A and B? How many? 4 of them. All right, now, I'm going to put these in what's called a gray code, not a counting code. So I'm going to start 0, 0, and I only want one variable to change at a time. Next one seems logical, 0, 1. The next 1, 1, exactly.
1, 0.
And then 1, 0. Everybody all right with that? All right, now, what makes this function 1? Well, if I have 1, 0, 1, does not my function become 1? 1. So A's a 1, B's a what?
0.
So I'm down here someplace, right? And what's the C need to be?
1.
So I put a 1 there.
Why are there 2 zeros at the top for C? Oh.
Because I made a mistake. Just check it. Everybody okay with why I lit that cell up with a 1? Okay. Now, if this guy becomes a 1, what happens to the variable, or to the function?
It goes
It goes to a 1. What 0 and 1 pattern for the inputs makes this term go to a 1?
0, 1.
Okay, 0, 1. So do you see I'm along here someplace? And what has the C's got to be?
1.
1. Everybody okay with that? Okay. What about this term here? 0, 0,
0.
0. Now, it turns out, now what about the rest of the cells though? All zeros. Now, can I put those, what's the largest group of 8 I could possibly, or just give you the answer. What's the largest possible group of 1s I could have? 8. Do I have?
No.
Next largest. But I only got what? So that doesn't work. How about groups of 2? Turns out I don't. Can I get from this one to this one by only having one variable change through some path? How about from here to here?
So visually, they have to be adjacent.
Yes. But the edges wrap around. Side edges wrap, the top edges wrap.
Okay,
so. Okay. So it turns out I cannot simplify this function at